So write down what is a differential equation. An equation containing derivative or differential an equation containing derivative or differential of an unknown function is called a differential equation. An equation containing derivative or differential of an unknown function is called a differential equation. For example, dy upon dx equal to e power x. It is a differential equation. D square y upon dx square plus of y is equal to 0 is a differential equation. X dy plus y dx is equal to 0 is a differential equation. D square y upon dx dy upon dx plus 2x upon 1 plus x square into y is equal to x cube. So these are all the examples of a differential equation. Okay. I hope it is clear to you. Tinmoy, is it clear? Vishnu, Som, Ramyajit, Nasrin. Okay. Then come to order and degree of a differential equation. Order and degree of a differential equation. Order and degree order and degree of a differential equation. Write down order of the highest order derivative. Order of the highest order derivative that appears in the equation order of the highest order derivative that appears in the equation is called order of the differential equation. Order of the highest order derivative that appears in the equation is called the order of the differential equation. You see, suppose y is a function of x. So dy upon dx is called first order derivative. D square y upon dx square, which is nothing, that is derivative of dy upon dx, is called second order derivative. dqy upon dx cube is called third order derivative, and dny upon dxn is called nth order derivative, right? So order of a differential equation is the order of the highest order derivative that appears in the equation. For example, if an equation is like this, d square y upon dx square plus 2x into dy upon dx is equal to y, then this differential equation contains highest order of the derivative is 2. So we can say that the order of the differential equation is 2. Order of the differential equation is 2. Okay. Clear? If an equation is like this, dqy upon dx cube plus 3d square y upon dx square equals to sin x, then we can say that order of the differential equation is 3. So order of the differential equation means order of the highest order derivative that appears in the equation, right? Then come to degree of a differential equation. 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 Write down the highest power of the highest power of the highest order derivative. The highest power of the highest order derivative the highest power of the highest order derivative that appears in the equation is called degree of the differential equation. It's called degree of the differential equation. The highest power of the highest order derivative that appears in the equation is called degree of the differential equation. So come to an example. Suppose an equation is like this: d square y upon dx square plus 2x into dy upon dx whole to the power 3 is equal to y square. So find the order and the degree of the differential equation. Order is the highest order derivative. Here highest order derivative is d square y upon dx square, hence order of the differential equation is order is 2. What is degree? Degree is the highest power of the highest order derivative. Highest power of the highest order derivative is 1. So we can write the degree is equal to 1. Most of the students commit the mistake. They write degree is 3. Degree is not 3, degree is 1. Degree is the highest power of the highest order derivative. Highest power of the highest order derivative is known as degree. Chinmay, is it clear? Chinmay? Nasrin, Pankaj, Som. If you want to find the degree of a order and a degree, you will see what is the highest order derivative present in the equation. The highest order derivative is known as the order of the differential equation, and the highest power of the highest order derivative is known as degree of the differential equation. Take another example. Suppose an equation is d square y upon dx square whole to the power 3 plus 2 dy upon dx plus y equals to 0. Here order is 2. Order of the differential equation is 2 and the degree of the differential equation is 3. Order is 2 and the degree is equal to 3. Right? Then come to some important points to find order and degree of a differential equation. Note point 1. To find order and degree of a differential equation. To find order and degree of a differential equation. To find order and degree of a differential equation, the equation should be free from free from radical sign. The equation should be free from radical sign. That means if the equation contains square root of dy upon dx or cube root of dy upon dx or it's a higher order or fourth root, the equation should be free from the radical sign, means shorts. Okay. For example, an equation is like this: square root of dy upon dx plus 1 is equal to y. Square root of dy upon dx plus of 1 is equal to y. To find the order and degree, we have to remove the radical signs. Then squaring both sides, we can have dy upon dx plus of 1 equals to y square. Dy upon dx plus of 1 is equal to y square. Now we will find the order at 1. So order of the differential equation is 1 and the degree is equal to 1. Order is 1 and the degree is equal to 1. So to find the order and the degree, first of all, we have to remove the radical signs from the equation. Okay. Then note point 2. If the differential equation is not a polynomial equation, if the differential equation is not a polynomial equation, if the differential equation is not a polynomial equation in dy upon dx or its higher orders, then degree of differential equation cannot can't be determined, then degree of differential equation can't be determined, right? First of all, note it down, then I'll explain it. If the differential equation is not a polynomial equation in dy upon dx or its higher orders, then the degree of the differential equation cannot be determined. That means the property says that if dy upon dx or its higher order is an argument or input of a transcendental function, then its degree cannot be determined. For example, an equation is like this: d square y upon dx square plus 2xy equals sine inverse dy upon dx equals to sine inverse dy upon dx. Here the order of the differential equation is 2. Order of the differential equation is 2, but degree cannot be determined because here sine inverse is a transcendental function. dy upon dx is an input element for sine inverse x, or called input element is otherwise known as argument. So dy upon dx is an input element for sine inverse x, and its degree doesn't exist. Okay. Or we can write dqy upon dxq plus d square y upon dx square is equal to e raised to the power dy upon dx. Here order is 3 and a degree doesn't exist, right? I hope it is clear to you. Vishnu, Chinmay, Pankaj, Nasrin, is it clear? Write in the chat box. Okay, then come to next point, note point 3. If the solution of a differential equation 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 contains if the solution of a differential equation contains n distinct arbitrary constants, if the solution of a differential equation contains n distinct arbitrary constants, if the solution of a differential equation contains n distinct arbitrary constants, then order of the differential equation if the solution of a differential equation contains n distinct arbitrary constants, then order of the differential equation is n. If the solution of a differential equation contains n distinct arbitrary constants, then order of the differential equation is n. Okay. So let me explain it through an example. Suppose a differential equation is like this. D square solve d square y upon dx square. D square y upon dx square is equal to e raised to the power x. Okay. Suppose this is the differential equation. We have to find the solution of this differential equation. So order of the differential equation is 2 because highest order derivative is 2, right? Now solve it. Let us assume dy upon dx is equal to p. So this taking derivative of both sides, d square y upon dx square is equal to dp upon dx. So dp upon dx equals to e raised to the power x. This implies integral dp is equal to integral e raised to the power x dx. Integration of dp is p equal to integral e raised to the power x dx. Integral e raised to the power x is e raised to the power x. What is p? P is dy upon dx plus of arbitrary constant c1. So dy upon dx equals e raised to the power x plus of c1. Again integrating. Again integral dy is equal to integral e power x plus c1 into dx. This is equal to integral e raised to the power x dx plus c1 integral dx. C1 integral dx. This is equal to e raised to the power x plus c1x plus c2. So this is the solution. So y is equal to, the solution of this differential equation is y is equal to e raised to the power x plus c1x plus of c2. The solution of this differential equation contains two distinct arbitrary constants. One is c1, other is c2. Hence, the order of the differential equation is 2. Okay. So I hope it is clear to you. Tom, is it clear? आउथरे टिके बुझे देबे यस चिन्मय आउथरे बुझे देबा बुझिए ओनी रियल मी राइट योर नेम ओके बुझो जी ते कोची if the solution of a differential equation contains n distinctly arbitrary constants, then order of the differential equation is n. If the differential equation is given, you can find its order. कहीं देखा जी हाईएस्ट ऑर्डर डेरिवेटिव अच्छी suppose the equation is d square y upon dx square plus 2xy into dy upon dx is equal to x square. Then order of the differential equation is 2. If equation is given, it is very easy to find out its order. But if the solution of the equation is given, then how will we find the order of the differential equation? If the solution of a differential equation contains n distinct arbitrary constants, then order of the differential equation is n. Take the example d square y upon dx square. This example through d square y upon dx square is equal to e raised to the power x, right? From this equation, it is clear that order of the differential is 1, order of the differential equation is 2, and the degree is equal to 1. Okay, order is 2 and the degree is equal to 1. Let us solve this differential equation. To solve this type of differential equation, let us consider dy upon dx is equal to p. Let dy upon dx is equal to p. On differentiating both sides, d square y upon dx square equals dp upon dx. D square y upon dx square is equal to dp upon dx. So this equation can be written as dp upon dx is equal to e raised to the power x, right? So this implies on integrating both sides, so dp is equal to integral e raised to the power x dx. Integration of dp is p is equal to integration of e power x is e power x plus arbitrary constant c1. What is p? Initially we have assumed dy upon dx is equal to p. So dy upon dx equals e raised to the power x plus c1. Again integrating integral dy equals integral e raised to the power x plus c1 dx. So y equals integral e power x is e power x, integral c1x plus another constant c2. You see, solution contains two distinct arbitrary constants c1 and c2. Hence, order of the differential equation is 2. Okay. If the differential equation is not given and its solution is given, then how to determine its order? You have to count how many distinct arbitrary constants are there in the solution of the differential equation. If the solution contains n distinct arbitrary constants, then we can say that order of the differential equation is n. Chinmay, is it clear to you? Chinmay and Realme. Who is Realme? Realme. Write your name. Chinmay, is it clear? Chinmay, can you hear me? Why don't you write in the chat box? Yes, sir. Degree determine करियो भी ए सेम way ना सेमती डिग्री डिटरमाइन करियो बनी in the same way you can't determine its degree. Okay, only you can determine its order. Clear? Okay, Nasrin को बहुत दिन ला क्लास करनो थिलो absent रहउथिलो then come to एटा टिके प्ले differential equation टिके हमरो general equation थारो टिके different हमें general equation आगे equation solve करिया सिके तापर equation form करिवा सिके एठी कोन करे आगे equation formation सिखिबा तापर equation solve करिवा सिखिबा प्रथमे हमें सिखिबा formation of equation then we'll go for solution of differential equation. Okay, so write down formation of a differential equation. That means if the solution of a differential equation is given, then how to find the solution of how to find the differential equation. Solution of a differential equation is nothing a family of curves. If the equation of a family of curves is given, then how to get the differential equation of the family of curves. So write down formation of a differential equation. Formation of differential equation. Formations. Sir, mote Pankaj SMS kari disturb karuchanti. What can I do for you? I don't know who is Pankaj. I am taking the online class. Why don't you block him? Pankaj, why you are disturbing somebody? Pankaj, what is wrong with you? Why are you disturbing? Pankaj, please don't disturb. Pankaj, can you hear me? Acha, Realme, what is your name and you are from which higher secondary school? Okay, you want note. Which note? Sir, I just note. Okay. So if you want the note, okay. Pankaj, contact either Vishnu or Chinmay. They will provide you the note. Okay. Don't fight with each other. Okay. Don't fight with each other. Okay, Pankaj, you contact Vishnu or Chinmay. They will provide the entire note. Okay. Okay. Then come to formation of differential equation. How to form a differential equation if the solution of a differential equation is given? Solution of a differential equation is nothing a family of curves. If the equation of a family of curves is given, then how to find its differential equation? Okay. So step one, that the stepwise approach, which is known as algorithm. Step one, find the number of distinct arbitrary constants. Find the number of distinct arbitrary constants find the number of distinct arbitrary constants in the solution, otherwise known as equation of a family of curves. Equation of family of curve. Find the number of distinct arbitrary constants in the solution or equation of a family of curves. Step two, differentiate the given solution as many times differentiate the given solution as many times as the number of distinct arbitrary constants. Differentiate the given solution as many times as the number of distinct arbitrary constants. Step 3. Eliminate the arbitrary constants from the solution through dy upon dx or its higher orders. Through dy upon dx or its higher orders. The equation so obtained the equation so obtained is the required differential equation. So note these points. I will explain through examples. जे पर्यंत रिक्वायर्ड ऑर्डर ता न मिलिछि से पर्यंत डिफरेंशिएट करिबा हाँ आमे देखिबा केतेटा आर्बिट्ररी कांस्टेंट अछि जेतिटा आर्बिट्ररी कांस्टेंट अछि सेतिकी थरे डिफरेंशिएट करि पाय ताठू अधिक थरे डिफरेंशिएट करि परिबानी ताठू अधिक थरे डिफरेंशिएट करि कले हमको कोन सब एब्सोल्यूट डिफरेंशियल इक्वेशन मिलियो मु एग्जांपल थ्रू रे बुझेबी वर्तमान ओके क्विकली नोट इट डाउन लिख सारे पिले चिन्मय डन सोम बुझे होची चिन्मय हम देखो सपोज हमको देछि सॉल्यूशन ऑफ द डिफरेंशियल इक्वेशन y is equal to ax square plus bx. So this solution contains two distinct arbitrary constants. So maximum we can differentiate two times. Or differentiate kariya dy upon dx will be 2ax plus b d square y upon dx square is equal to 2a. Right? So we can't differentiate again. Write down questions. Form the differential equation of the family of curves. Form the differential equation of the family of curves y equals a sin x plus of b. Form the differential equation of the family of curves y is equal to a sin x plus of b cos x. Okay. This solution contains two distinct arbitrary constants a and b. So maximum we can differentiate two times. So order of the differential equation will be 2. Okay. Because the solution contains two distinct arbitrary constants. Y is equal to a sin x plus b cos x. So write down differentiating both sides. Differentiating both sides. So dy upon dx equals a into derivative of sin x is cos x plus b into derivative of cos x is minus sin x minus b sin x. Again differentiating both sides. Again differentiating both sides d square y upon dx square equals minus a sin x minus b cos x. If we take minus as common, minus of a sin x plus b cos x. So a sin x plus b cos x is nothing, only a function y, minus of, we can write y. Hence, the required differential equation is d square y upon dx square plus of y is equal to 0. This is the required differential equation. I hope it is clear to you. Som, it is clear? Rom, is it clear to you? Chinmay? Yes. Okay. Next question, try yourself. Form the differential equation of the family of curves y is equal to a sin inverse x plus of b cos inverse x. Form the differential equation of the family of curves y is equal to a sin inverse x plus b cos inverse x. Solve it. Tell me the answer. Y is equal to a sin inverse x plus of b cos inverse x. Come to the solution. Y is equal to a sin inverse x plus of b cos inverse x, and then differentiating both sides, differentiating both sides. Angru, okay. y double dash plus y is equal to 0. Okay, let me check. So dy, no, I think the answer is not correct. Nasrin, that's in physics node from Mahanadi Vihar Women's Higher Secondary School. Lecture in physics, nodal officer. So dy upon dx equals a into derivative of sine inverse x is under root 1 minus x square, and derivative of cos inverse x is minus 1 by, so minus b upon under root 1 minus x square. This is equal to a minus b upon under root 1 minus x square, right? So taking under root 1 minus x square into left hand side, the equation will be under root 1 minus x square into dy upon dx equals a minus b. Okay. As this differential equation contains a solution contains two distinct arbitrary constants. So maximum 2 times we can differentiate the solution. So again differentiating both sides. Again differentiating both sides. With respect to x. So d upon dx of under root 1 minus x square into dy upon dx equals derivative of a minus b. A and b are constants. So derivative of constant is 0. Now differentiating using product rule, derivative of under root x square 1 minus x square 1 by 2 under root 1 minus x square, and derivative of 1 minus x square is minus 2x into dy upon dx plus under root 1 minus x square into derivative of dy upon dx, that is d square y upon dx square is equal to 0. 2 cancels. After simplification, this one will be minus x dy upon dx into the plus under root 1 minus x square into under root 1 minus x square will be 1 minus x square into d square y upon dx square is equal to 0, or one minus x square into d square y upon dx square minus x dy upon dx is equal to 0 is the required differential equation. So did you understand, guys? Let me know through the chat box. Write in the chat box whether it's clear to you. Chinmay, Som, is it clear? Vishnu, Nasrin, Rajlakshmi, Pankaj. Okay. Then come to another question. Solve the differential equation of the family of curves y is equal to a e to the power x plus b to the power 2x. Y equals a to the power x plus b to the power 2x. Form the differential equation of the family of curves y is equal to a to the power x plus b to the power 2x. So guys, try to solve it. Take 2 minutes of time and try to solve. Try to form the differential equation of the family of curves y is equal to a e raised to the power x plus b into e raised to the power 2x. This differential, so this solution contains two distinct arbitrary constants. So differentiate 2 times this solution and eliminate the arbitrary constants a and b. Yesterday time in class and I think you are Rajalakshmi asking. Rajalakshmi, actually first session is from 7:30 to 9 and second session is from 9:15 to 10:45. Okay. But usually it will ends at 10:30. Today, due to heavy rain, I think you won't be able to go to your school or college. Better you attend the online class provided by the government of Odisha. Come to the solution. Y is equal to a e raised to the power x plus b into e raised to the power 2x. Now differentiating both sides with respect to x, dy upon dx is equal to a into e raised to the power x, b into derivative of e raised to the power 2x. So 2b e raised to the power 2x. Okay. This is equation 1. This is equation 2. Again differentiating both sides. D square y upon dx square is equal to a e raised to the power x plus 4b e raised to the power 2x. Okay. Now we have to eliminate the arbitrary constants a, b using equation 1, 2 and 3. If you subtract equation 1 from equation 2, equation 2 minus equation 1 will give you, so this dy upon dx minus of y equals a raised to the power x minus a raised to the power x cancels. So 2b e raised to the power 2x minus b e raised to the power 2x, that is b e raised to the power 2x. Again, equation 3 minus equation 2. Equation 3 minus equation 2, that will give you d square y upon dx square minus dy upon dx equals a e raised to the power x minus a raised to the power x cancels. 4b e raised to the power 2x minus 2b, so 2b e raised to the power 2x. Now in place of b e raised to the power 2x, we can substitute dy upon dx minus y. This is equation 4 and this is equation 5. Right, on substituting equation 4, substituting equation 4 in equation 5, we'll get d square y upon dx square minus of dy upon dx equals 2 into b e raised to the power 2x will be dy upon dx minus of y. Okay. This, so d square y upon dx square d square y upon dx square minus 3 dy upon dx plus of 2y is equal to 0 is the required differential equation. Is it clear? I hope it is clear to you. Chinmay, Pankaj, Nasrin. Then come to solution of a differential equation. Quickly note it down, guys. Okay, that done solution of a differential equation. Solution of differential equation. Solution of differential equation. Okay. Into first order, first degree, differential equation. First order, first degree differential equation. What are the formats of first order, first degree differential equation? dy upon dx is equal to f of x. dy upon dx equals to g of y. dy upon dx equals f of x into g of y. dy upon dx is equal to f of x. dy upon dx is equal to g of y. dy upon dx is equal to f of x into g of y. If the differential equation is in the third form, is known as variable separable form. Variable separable form. The first form is known as variable separable form. So it's third form. So if the differential equation is first form, then how to solve this? dy upon dx is equal to f of x. So this implies integral dy equal to integral f of x dx. Integral dy is y. So y equals integral f of x dx. This is the method how to solve if the differential equation is in the first form. Okay. Then come to second form. dy upon dx is equal to g of y. This implies integral dy upon g of y is equal to integral dx. So x is equal to integral dy upon g of y. Then third one, Quickly note it down. I will use the next page. Done. Okay. The third form is dy upon dx equals f of x into g of y. Dy upon dx is equal to f of x into g of y. This implies integral dy upon g of y is equal to integral f of x into d of x. So function of x should be taken towards d of x and the function of y should be taken towards dy. That's why it is called variable separable form. This is most important. Okay. So come to solve some differential equation. Solve dy upon dx equals x square plus 3x plus 1. Dy upon dx equals x square plus 3x plus 1. Come to the solution. So dy upon dx equals x square plus 3x plus 1. This implies integral dy equals to integral x square plus 3x plus 1 dx. So y equals integration of x square is x cube upon 3 plus 3x square upon 2 plus integration dxx plus of constant c. Then come to solve. Dy upon dx is equal to e to the power x minus y. This implies, come to solution, dy upon dx equals e power x minus y is e power x upon e power y. So using variable separable, integral e power y dy equals to integral e power x dx. This implies integral e power y is equal to e to the power x plus of constant c. Okay, quickly note it down. So guys, your first session is over. Okay. I'll start your second session exactly at 9:15. If you have not taken your breakfast, go and have your breakfast and join the class. And today's second session will be very amazing one. I'll solve different types of questions based on variable separable forms. And if time supports, then I will discuss some PYQs of 2025. Okay. Second session, I'll start exactly at 9:15.